first, very short introduction. My name is Igor Buzatović. I'm working as a principal software engineer in Porsche Digital Croatia, and I'm also tech lead on our Streamzilla project, which is our code name for Central Kafka Cluster. Basically, we have a hybrid Kafka installation with the on-prem solution and cloud Kafka. So today, I will talk a little bit about the Kafka and the other components from the Kafka ecosystem, and starting with the core Kafka, and then in the second part, I have a little demo for you, and I hope you will have enough time to go through it. So let's start with the presentation. Okay. So, if you worked with Kafka, you probably know about Kafka core components, which are basically the Kafka brokers, Zookeeper as a dependency for that, and also Kafka clients, which officially Java clients are the first one developed, but there are lots of different implementation in other languages. And then there are some other components that are not used so much, but we'll go through every of these components today and see what are they used for. So Kafka brokers and Kafka clients, meaning producers and consumers. So this is like basics. Yeah, as you might know, the core Kafka still depends on Zookeeper, although there is soon should be Zookeeper-less, and Kafka brokers should be able to do all the job that currently is done by Zookeeper. So basic unit in Kafka are topics. So like there are something like queues, or you can think about topics like that. But they are also partitioned, and there is more details in that part. And then for the clients, you probably know about producers and consumers, but there is also an admin client which can be used to do administrative tasks like creating topics and similar stuff. Okay, so let's move to the next component. This is Kafka Streams. Kafka Streams is built on top of the producer and consumer, and it is basically used for data processing. So it offers some additional features that producers and consumers themselves do not have. So in short, it's a client library. First of all, you can build it, you can add it to your application as a dependency, and you don't need separate cluster to run Kafka Streams. And as I already said, it's built on top of producer and consumer. It provides streams operations, so something similar to, for example, Java collection streams, operations like map, filter, aggregate, join. These are standard operations that Kafka Streams API offers. It is scalable. It inherits the scalability of the consumer, and basically that it uses that consumer rebalance group rebalancing protocol, and for that you can just have any number of instances of your Kafka Stream application, and it will automatically balance the workload. It's fault tolerant, so basically if you're running the Kafka Streams application and one of your nodes crashes, the other surviving nodes will automatically take over and continue the job where the crashed node stopped. Also, if you have only one node and if it crashes, once you restart it, it will just pick up where it stopped and continue the work. Okay, so now I have some slides that I will skip because in half an hour we don't have enough time for that, but we can get back to that later if there are questions regarding to it. Just short info, Kafka Streams has low-level API and high-level API. Basically, high-level API is mostly used and low-level API only in some special cases. The architecture, as I said, it's built on top of the consumer and producer. So partitions, as with consumers, are the units of parallelization. So if you have topics with multiple partitions, then your Kafka Streams application can use that and parallelize some work. You can have many instances running and reading the data and processing it from the same topic. One pretty important part of Kafka Streams are joins. They basically work similar to database joins, but of course in Kafka world. And then there is another concept called windowing. That means that every operation that we do, for example, some kind of aggregating, counting, we can also add time dimension to it, and we can window that results by some time periods, time windows. Kafka Connect is next component in Kafka world, and it is used to get data from external system to Kafka and vice versa. So basically, if you have a database or, I don't know, Elasticsearch or any popular system that many people use, somebody already programmed the solution to get the data from that system to Kafka, and that's why you don't have to do it yourself again. You can just install Kafka Connect cluster, or I don't know, provision it on Confluent Cloud SaaS solution, and you can just deploy one of, I don't know, hundreds of available connectors that can talk to the external systems and write data to Kafka, and as I said, vice versa. So some of the features of Kafka Connect, it can run in standalone or distributed mode, although I'm not sure why standalone mode is there, because they recommend to run it in distributed mode even for development and testing purposes. And then, as I said, many Kafka connectors exist. You can find them on Confluent Hub. There are some of them that are official, and some of them are free to use, some of them are commercial. And you can also write your own connector if there is no connector currently for that system that you want to use. There is an API, you have to implement it, and you can also then, if you want, submit that connector to the Confluent Hub for other people to use, or you can sell it, of course. There is a simple configuration of the JDBC sync connector. We'll talk about it later, so I will just skip also these slides that are explaining how the tasks are distributed over the Kafka Connect cluster. Maybe I missed to say that the Kafka Connect is separate cluster. It's not part of the Kafka cluster, of the main cluster. So it's basically more like a client to Kafka brokers. It's basically also built on top of the producers and consumers. And here we have some example of how tasks can be arranged when we have multiple sources in the external system. Okay, next component is KSQLDB. So this is again a totally independent component. You can set up KSQLDB cluster, and basically it is used, it is next level of Kafka Streams. If you want to use Kafka Streams, you have to have your own application, add Kafka Streams library to it, and use this Kafka Streams DSL language to actually process the data, right? With with KSQLDB, you don't have to have your own application. You can just set up something like, let's say, jobs that are running inside KSQLDB, and you do it by issuing an SQL-like commands. So basically, you don't have to know any programming language for that, besides that SQL-like language that KSQLDB uses. So using that language, you can deploy persistent queries, and persistent queries, they say it's a nightmare of every database administrator, because these queries never end. And basically, they are practically jobs. So basically, you have some query that tells KSQLDB, okay, read from the topic A, and then do something with the data. and then output the results to another topic, right? Okay, so this is first type of the query. Then you have also push queries, which can be used to get the data to listen to the events, to the changes on the topics. You are mostly interested in the resulting topic, that is storing the results of the processing of the persistent queries. And there are also pull queries, which can be used to get the current state of the underlying state stores used by Kafka's KSQLDB persistent queries. There is also integration with Kafka Connect, so basically you can use KSQLDB to manage Kafka Connect connectors, but it's easy to manage them without it via REST API of Kafka Connect, so that's just like a bonus. The next component is Kafka REST proxy. So in a situation where you don't want to build your application around some client libraries for Kafka, like Java or Python or any other existing library, you can just use REST API and produce or consume data via REST API using whatever library you want for HTTP communication. It's a little bit more complicated because you have to issue several REST API calls to set up your consumer, for example, to register it, to add it to the group, subscribe it to some topics, and then after that you have queries that actually fetch the data. And it's also, performance is a little bit slower than using clients because there is a HTTP protocol which is not so efficient in this case. Yeah, so basically everything on this slide I already told you. So to demonstrate how all these components are used, I have a little application, and the idea behind this application is that we are building some bookshop web application that has basic functionality like purchasing books and rating books. So these events would usually come from real users, of course, but in our case we will mock that part, we will simulate user events. The application itself is Spring Boot application, and then all these components, not all of them, but some of them are used, like Kafka Streams, Kafka Connect, and KSQLDB, to actually get to our result, which is these reports, real-time reports of how much time specific book was sold, and also what is the current rating of the specific book. The architecture of that application looks something like this. So we have our Spring Boot application, which is connected to the database. Database holds the books themselves with the title, author, and ISBN of the book. And then we have Kafka Connect. And the first connector that we are using is JDBC connector, which is taking these books from the table and storing that to Kafka topic. Why do we do that? Because we need that data to enrich the purchases and the rating events. Then we are using KSQLDB actually for one of these reports. And the first one is done by Kafka Streams inside the Spring Boot application. So I wanted to show both cases, both ways how to process data with Kafka. And then in the end, after the data is processed, we have the results in the resulting topic, and that topic is then ingested by Elasticsearch connector, and it outputs the data to Elasticsearch. And once the data is in Elasticsearch, we can easily use Kibana to visualize these graphs. Okay, so now I will switch to the application. We are on a half time so that I think we will have enough time for this. So, first step is actually to run all the Dockers. In Docker Compose, I have several Docker images that are run, but it's not very important. You can always look at that in the code, and I'll just run compose up, so you can see what components are being ran. So it's running, but it takes some time for example, for Kafka Connect to warm up. And how do we see what's happening? We will use Insomnia for issuing REST API calls, so we can see what's currently the status of Kafka Connect. It's a little bit slow, but we are getting there. So if I just say list connectors, I'm still not getting a response because Kafka Connect is not up yet, but it will be in short. But I can check, for example, if schema registry is ready. Yeah, schema registry is up. So also I'm using schema registry here. So Kafka for itself doesn't know anything about the structure of the data. So it's all byte arrays to the brokers. And if you want to have a structured messages, then you need to use schema registry, which in this case I'm using with Avro format. And basically that makes our data more readable and maintainable. So let's check again for the connect. Yeah, it's up. Okay, so first I will start the application, Spring Boot application. And that application, during the startup, will create a books table and fill some sample data in it. So I guess it started. I hope there is no errors. Okay. So if I look at the database here, there should be already books. Okay, let's see. Yeah, here we have some books. Okay, so now we have the application running. The next step, if you remember the graph, is to get these books to Kafka topic, right? So to do that, we will use Kafka Connect, JDBC source connector. Source connector means that the external system is the source of the data, and in the sync connectors, the external system is the destination. So let's deploy our Postgre or JDBC connector, which is connecting to the Postgres SQL. And if you look at this, it's a little bit tiny, but the main part of this configuration is to give this connector the URL of the database, username, password, and to give that a list of the tables that we want to ingest. And there are some other transformations here to get the ID column and use it as a key and so on. Actually, as ISBN column to use it as a key for the messages. So if I send it, it's deployed now. I can check the status of its task, and it says it's running. So basically now I have this data in Kafka. The important part of the application here is this class, which actually uses Kafka streams. And the most important part of this class is this create topology method. Topology means how do you want to process the data. Basically, you are using this DSL language to chain different operations and to output the results to Kafka. Of course, in the beginning, you have to ingest this data from Kafka. So basically, we are doing that here using book purchases topic. So this Kafka Streams application is handling purchases. It will just count the purchases per time and per book, and store it to the external, to the resulting topic. The second part is actually this time windowing. So we are windowing these counters by 5-minute time windows. Usually, I mean, in real world, it will probably be like 1 day or something like that. And the granularity of this time window size is basically up to the use case. I think in some kind of bookshop example, it would be good to have 1 day time interval. Then, once we have these time windows counters by days, then we can just sum it up and let's say get the data for the last week and sum all these rows, which are just 7 rows, get from the Elasticsearch, and then we have nice presentation of that. So the data becomes queryable once it's outputted to the external system that is suitable for that, like Elasticsearch in our case. And the third step here is to enrich this data. So now we have counter by ISBN, which is some kind of ID of the book, and then we are adding actual book title and author to this data. So once we export that to Elasticsearch, we have complete data in it. Okay, so to check if this is working, we can actually, I think this is too small, but can I make it a little bit bigger? Not so easy, but let's say I will just list the topics. It's really small. Let me just try something. Okay. This is better. Okay, so we have all the topics here, and we see books topic, which is created from the Kafka Connect. We see some topics that are stored, where the purchases events are stored. But then we see some funny named topics, which are basically generated by the Kafka Streams application and used to store as a changelog for the state store, and also for repartition when we are changing the keys. But to move on, let's see next step, and that is for the ratings. We are using different approach. We are not using Kafka Streams, but we are using KSQLDB. So for KSQLDB, I have prepared here a list of queries that we need to issue. But first, we'll have to connect the Docker with the KSQLDB client. Okay, now we have the connection to the KSQLDB. And now, similarly, as you saw with the Kafka streams, there are several steps for these Kafka KSQLDB SQL-like commands to create streams from some topics, to actually create a table from the books topic, and then actually to do something like getting the average of the rating per book. So ISBN here is the key. And then in the end, to enrich this with the data from the books topic. So I will just paste all of them together because I don't think we have enough time going into more details. And I'll run it. Oops. Of course, demo. Sorry. Oh, okay, book ratings doesn't exist. So let's see. We have another application here which is simulating the readers. So let's run it. And this is basically just randomly purchasing a book and randomly rating the book. And let's see if there is more luck with this now. Yes. So basically now we should have the results in two separate topics, one for the book purchases counts and the second for the book ratings. And to get it visualized by Kibana, we need first to move that data from Kafka topics to Elasticsearch. So for that we will use another connector. We will deploy another connector, Elasticsearch sync connector. And basically here, the only interesting configuration is which topics do we want to move. So I will just run it, and it's up. And if we list connectors now, we should see 2 connectors. Yeah, we do. And basically that's it. Everything is done. We can just go to Kibana and configure the visualization. So it should be up and running. And the first step here is to actually get these index patterns. And we will create them. We have here already indexes are there, so the Kafka Connect is pushing data to Elasticsearch already. But we need these indexes just for visualization part. So let's add this one. And I will already add the another one. And we are basically near the finish line. So we have indexes now. We can build our dashboards. Creating visualization. So now we will first take this book purchases count index, and we can just add, I don't know, book title as x-axis, and the count should be in y-axis. And we don't want median, we want the sum. Why the sum? Because as we said, there are multiple windows. Counters are separated into multiple windows, and in this case, we want to know all the purchases for the books. We could query it by some specific dates, but in this case, we will just take them all. And the second visualization would be regarding the ratings. So again, we will use title here on the X, and average rating on the Y. And basically that's it. We can save it. We can save this, give it some name. And this is it. If we now switch to automatic refresh every 1 second, we will see these changes in real time. So basically we have a full data pipeline from the input from the website and from the database to the real-time reports running in Kibana. And if I used only KSQLDB, I would have even less code. So basically only thing that my Spring Boot application would do is receiving these purchase events and rating events. Yeah, so I think that gives us exactly in time, right? Cool. So, any questions? Nope. Regarding this code, I think I have somewhere the link to my GitHub repository. Yeah, here it is. So in this GitHub repository, you have all this code used for that, all the Docker Compose configuration, and also there is a README which guides you through the steps that I showed here. So thank you.